Hello, welcome back to our channel. Today we are solving another problem from the CSES problem set. In this video, we'll discuss the efficient solution and also the logic behind the problem. So without wasting much time into this, let's dive in. We're discussing maximum XOR subarray. Now let's understand what the problem is actually saying us and how we can efficiently solve this. So the problem statement says, given an array n, your task is to find the maximum XOR sum of a subarray. We are given with the inputs, and then we are to find the maximum XOR sum in the subarray. Okay. So we have understood the problem. Now let's discuss what the problem is actually saying. Okay. So the problem is saying we are given with an array, and we have to find a subarray from any I to j whose XOR from I to j is maximum. Let's discuss with the test case that is given to us. So test case is 5, 1, 5, 9. So let's find the XOR for all the possible subarrays in this. So subarrays are 5 is a subarray, so it would be 5. 5, 1 is a subarray. XOR would end up getting for 5 it's this, and for 0 same it's 0. So it would end up getting 4. Then we have 1, 5 is also 4. Then we have 5, 1, 5 as a subarray. This would be 1. Then we have 5 and 9. 5 and 9 would be 12. And then we have 1, 5, 9, that would be 13. So we can see the maximum XOR that we can get for a subarray 1, 5, 9 would be 13. So that would be our answer. But if we go now, let's see how this time complexity, or like why this solution is efficient or not, or why we cannot go with this approach. This is actually a brute force approach. It's actually a brute force approach. We would be finding all the possible subarrays for an n, for all the n numbers, and that would be not in the that would not be line that complexity. Like that would be high in complexity. Now let's see how we could actually optimize the solution. Like the solution would be a bit tricky, so let's see how we could optimize the solution. So first thing that we have to look, like the first key insight I would say we can look into this is, let's suppose I have an array prefix of I. Like I have defined an array prefix of I. Prefix of I gives me all the XOR, like gives me the XOR for all the elements in 0 to I. Like it would give me the XOR for all the elements in 0 to I. So if I want to find the XOR from j to I, then my answer would be prefix of, so my prefix for j to I would actually be prefix of j minus 1 XOR prefix of I. I'm sure this is understood. Okay, so I'll explain this also how we actually comes to this equation. Let's see. So let's suppose you have a XOR. Let's suppose you have an array from 0 to n, and we have an I. Let's suppose the XOR from 0 to I is a, and for XOR 0 to j is b. Now you know for 0 to I it would be a, and for 0 to j it would be b, and now you have to find the XOR from j to I. It would simply be a XOR b, like not exactly a XOR b, but yeah, from j minus 1. Like let's suppose till j minus 1 it's b, then it from j minus to j to I it would be a XOR b, because when you are XORing these elements, like you need to just XOR these elements, it would be XOR, getting the XOR for all of these, and then doing the XOR with these elements would actually give you these only elements. Let's suppose I have an array 1, 5, 5, 9. So if I know the XOR for this and also know the XOR for this, so if I do it 1 XOR 5 XOR 5, and then I do again the XOR with 1 XOR 5, so I would actually eventually cut these off, because, and we all only get this element, and this is only the middle element, or I would say the remaining element in j to I. So here is how we land up with that equation that we have found. So first insight that we have to look into is that now the second thing that we have to look into this is, we can say if we know all the prefixes, if we know all the prefixes that are stored, then we could easily find the solution with and finding the maximum prefix from it. Now the question arises how we are going to store all these prefixes and also finding the max in all those prefixes. To store all these prefixes, we would be using our trie data structure, because trie is a very efficient data structure in this and would actually be helping us, because we would be storing the bits of each number, and that would actually be helping us in optimizing the space and also in traversing through all the bits one by one. And for finding the new prefix, if we want to find the new prefix, it would be, we would then construct a value from the, like it would be uh, like new prefix would actually be a maximum XOR. Like you have to find the maximum XOR by getting the opposite bits from the trie. Let's suppose if I finding the XOR for this, then XOR would only be maximized if I found the maximum number of opposite bits I could find from MSB to LSB, right? So let's understand this approach with an example. Let's suppose I have a this array I have been given. Okay. So initially our trie would be storing a 0. Like a trie would initially be having an empty trie. So when we are inserting 8 into this, so 8 would be 1,000,000. It would be 1,000,000. So our trie is having 0 already in it. So the maximum XOR, so let's find the prefix. First find the prefix. So our prefix would be 0 XOR 8. It would be 8 only. Okay. Now we are going to find the maximum possible XOR in our array for our 8. So maximum possible XOR is, initially in our trie we only have 0. So the possibility of maximum XOR is doing the XOR with 0, and it would be 8 only. So our current max would be 8. Okay. And we have pushed the 8 element into our trie. We have pushed 8 into the trie. Now let's move to another element, that is 1. Okay. Now let's see how we are going to find the 1. Okay. So for 1, our prefix is 8, and we are doing the XOR with 1. So our prefix would then go to 9. Okay. Now we are going to find the maximum XOR which I could make from 9. So our 9 bit wise would be 1,000,001. So for this, to maximize the XOR for 9, I need to find the 0. If I find the 0 for this MSP, then 1, and then 0. If I could find this possible, like this would be the maximum. If I find this in my trie, I would find the maximum for this. Okay. So in our trie we have 0 and 8. For 0 and 8, I can find for 1, 0 can exist. 0 exists. For 0, 1 does not exist, so I have to go with 0. For this 0 also, 1 does not exist, so I have to go with 0. And for this 1, 0 exists. So actually we find the number 0 for 9. So our maximum possible XOR would landing by 9, and then we insert this prefix into our XOR, into our trie. Now let's move to another element, that is 2. Like from this 8, 1 to 12. Now we move into 2. Our prefix was 9. So 9 XOR 2 would be 11. And our trie is having 0, 8 and 9. Okay, now we have to find the maximum for this 11. So binary representation for 11 is 1011. Now let's see how we are finding the, like, what would be the maximum possible for 11. So maximum possible for 11 would actually be, if we see, we could find, like, let's find the binary binary representation of all of these, and for 9 it might not be 0, 1. So we could see the maximum we could go is getting XOR with 8. If we do the XOR with 8, we could find the maximum, like the best match would be 3. The best match is going to be 3. And we would then insert 11 into our try. After that we have 12. For 12 our prefix would be some prefix would be 11 or 12. It would be 7. And then we would find the maximum, or like, or the best possible XOR for the 7. So best possible XOR for 7 would be, if we see, now we have 11 also in a try, it would be 1 0 1 1. So if I say what for 7, our binary representation would 7 would something look like 0 triple 1, and the best possible suit for 7 would lie up in 8, and it would, if we do the XOR with 8, it would give me 15. So our maximum possible answer is 15 for this 8122. So this is how our try approach could look like. We would finding the prefix all the time, and then from that prefix we are going to find the best possible matching number with that prefix we could make the XOR with, and then inserting that prefix and finalizing our maximum XOR that we have found till now. Let's understand this with a kind of a pseudocode for now. So this is how our pseudocode would look like. So if we have an array, and we have, let's suppose we have defined a try structure, okay, and when we are traversing, like, for initially our max would be at 0, our prefix would also be at 0, prefix max XOR that we would define. We'll insert our try dot insert at 0. We insert the 0th element. Then from each 0 to n, our prefix would be XOR with a of I. Okay. Then we will find the current max. That we have current max would be actually the we would go and find it from try dot find max XOR. Okay. We'll pass the prefix XOR, and we'll update our max answer to max of max comma current, and then we would insert try dot insert our prefix XOR. So this is how our pseudocode would look like. I would share the code in the description. Have a look at that and let me know in the comments if you find any difficulty understanding this. I know it's a tricky problem as try is not an easy data structure to understand, but this is the most efficient approach, and it would give me O of n time complexity and O of n space complexity. Yeah, so thank you everyone. Please do like, share and subscribe the channel for more videos, and let me know which another problem you are facing the difficulty in. We'll make a video and explanation on that as well. Thank you.